Okay, college algebra. This is section 3.2. This is our second lesson in the intro to right triangle trigonometry. So first thing first, you should have your calculator every day in class. That's the way it's going to be until spring break. One of the first things, we're going to be dealing with calculators where we have to answer angles in degrees. There are other measures we will come to later. So you need to make sure when you go into your calculator and you go into the settings and you look at the document settings where it says angle, right now mine says radian, it needs to say degree. Okay, so the angle, it needs to say degree. Once you set this, it should be good. So again, I did document, I did settings, document settings, the angle should reflect degrees. Okay, then my calculator is ready to go. So once that is set, we should be good to go. Let's look at something where, so when you look at something like this, I'm solving an equation, tangent of x equals, tangent of 44 equals x over 16. So when you see the tangent function, you know that's opposite over adjacent. What you're seeing there, the 44 degrees, that is the angle. And then what you see over here, the x over 16, those are sides of a triangle. So in this case, I could draw a triangle, but I don't really know how to find the exact answer. I need my calculator to do this. So what I'm doing, I'm solving for x. You can multiply both sides of that equation by 16, and you get x equals 16 times the tangent of 44 degrees. So on your calculator, you just need to do 16 times the tangent of 44 degrees. So on my calculator, I'll just do 16 times, and now to get to the tangent, if you look to the left of the 7 key, there's a trig button, and so you just pick the function. It's the tangent, so 16 times the tangent of 44 degrees, hit return, and 15.451. So my answer is 15.451. So 15.451. Okay. Solving these equations for x. So in this problem, I need to solve for x. So if I multiply both sides by x, that would give me x times the sine of 39 degrees equals 12. And now to solve for x, x is going to be 12 divided by the sine of 39. So that's what goes in my calculator, 12 divided by the sine of 39. So I go over here, 12 divided by trig function, the sine of 39. So 12 divided by the sine of 39 is 19.068. So 19.068. Cosecant of 71.7 equals 24. If you multiply both sides of this equation by 24, you're going to get x equals 24 times the cosecant of 71.7. So again, same thing, just do this on my calculator. 24 times trig cosecant 71.7. 25.278. 25.278. Did I do that right? 25.278. Yep. X squared equals, x squared over 2 is equal to the cotangent of 14.4. So I'm trying to solve for that x. So what I'm going to have here is x squared equals 2 cotangent 14.4 degrees. So x squared equal, so 2 times the cotangent of 14.4. So 2 times the cotangent of 14.4. So that's 7.789. Well, that's x squared. So x is going to be plus or minus the square root of that. So on my calculator, I can just go up and say I need to take the square root of that number right there. So the square root of that number, so 2.79. So your answer here is going to be plus or minus 2.79. Secant of 12 degrees equals x over 134. Solving this for x, you get x equals 134 times the secant of 12. So 134 times the secant of 12. So the secant of 12, 136,994. Tangent of 90 degrees equals x over 4. This means that x will equal 4 times the tangent of 90. So I just go to my calculator, 4 times the tangent of 90, and I get undefined. Okay, so we have not covered yet why this is undefined, but if this happens in your calculator, there are certain things that are defined and not defined we'll get to yet. So this one is just undefined. Now, in every case of what you just saw, I gave you an angle, a trig function, and you were solving for one of the sides of the triangle, either the opposite, the hypotenuse, the adjacent. Now what we need to do is we need to solve using the inverse function. So how would I solve something like the sine of x is 1/2? That's saying go find, here you can clearly see I'm solving for the angle. What angle has a sine of 1/2? So an angle that has a sine of 1/2. Well, we can draw this with triangles, an angle that has a sine of 1/2. It would look like that. So that would be the angle. So that would tell me, I know that the sine of that angle is 1/2 because this side is the opposite and this side is hypotenuse, and you can clearly see that the sine of that angle is 1/2. But I need to know what is that angle. So how do I find that angle? So what we need is the ability to have an inverse function. So sine has an inverse function called sine inverse. It's not cosecant, that's the reciprocal function. So if we had this, so the sine inverse of sine x, if you take the inverse function of both sides, remember what happens when you apply a function and its inverse. They undo each other. That's how I can solve for this variable x. So anytime you're solving for the angle, you're going to have to use the inverse sine function. So what you should be able to do is go straight from here and say, I am solving for the angle. So x will equal the inverse sine of 1/2. So you're saying, what angle do you take its sine and get 1/2? Well, take the inverse sine of 1/2 and you'll get that angle. So I can do that on my calculator. So I can go back to my calculator and just say, let's take the inverse sine of 1/2. So hit that trig button. You see the inverse sine function. So the inverse sine of 1/2, and I get that to be 30. So the answer here is 30, but keep in mind I have solved for an angle. So the answer here is 30 degrees. So anytime you're solving for the angle, right here, your answer will be in degrees. Cosine of theta is 0.784. I'm solving for the angle theta. So theta is going to be equal to the inverse cosine of 0.784. Inverse cosine of 0.784. So on my calculator, I would just go to the inverse cosine of 0.784, and that's 38.37. So the answer there is 38.37. Answer here is degrees. I have solved for an angle. Next one, cosine beta. I'm solving for angle beta. So angle beta is going to be equal to the inverse cosecant. So the inverse cosecant of 81 over 43. Inverse cosecant of 81 over 43. So trig function, the inverse cosecant of 81 divided by 43 is 32.06. So 32.06 degrees. Cotangent of theta is 12 over 21, solving for angle theta. So angle theta is going to be the inverse cotangent of 12 over 21. So inverse cotangent of 12 over 21. So the inverse cotangent of 12 divided by 21 is 60.25. So 60.25 degrees. Tangent of theta is 44 over 77. I'm solving for the angle. Theta is equal to the inverse tangent of 44 over 77. So inverse tangent of 44 over 77, the inverse tangent of 44 divided by 77, 29.74. So 29.74 degrees. Secant of alpha is 9/4. So that means that alpha is the inverse secant of 9 over 4. So the inverse secant of 9 over 4 63.61. So 63, what was that again? 63.61. 63.61 degrees. So what you need to do is you need to be able to use the TI Inspire here to solve all 6 trig functions. Understand the difference when we're solving for a side versus solving for an angle. When you're solving for a side, like we did in the first one, your goal was to isolate the x and then just input in the calculator what you had. When you're solving for the angle, every time here I had to use the inverse function. So the inverse cosine, inverse cosecant, inverse cotangent. Okay, that's the way you solve for the angle, and right now the angles are solved in degrees. Let's look at a few examples here where I have it visually. We're going to do word problems later that allow us to do things like this, but solve for y. Now what you need to do is recognize what I'm looking at. Looking at that angle of 36 degrees. If I look at that angle that's 36 degrees, side y is opposite. Side 15 is the adjacent side. So what trig function or functions deal with the opposite over the adjacent? Well, that's going to be the tangent. You know that the tangent of 36 degrees has to equal opposite over adjacent, which is y over 15. So y is equal to 15 times the tangent of 36 degrees. This is going to allow me to solve for y. So 15 times the tangent of 36. So 15 times the tangent of 36, 10.89 or 10.90. So that tells me that that side y is 10.90. Did I do that right? 10.90, yep. Solve for side z. Look at angle 36 degrees. Relative to the angle 36 degrees, this is the adjacent side, and this is the hypotenuse. The trig function that deals with adjacent and hypotenuse is the cosine. So the cosine of 36 degrees is equal to 15 over z. If you multiply both sides by z, you get z times the cosine of 36 equals 15. Divide by cosine 36, z equals 15 over the cosine of 36. So 15 over the cosine of 36, that's what goes into my calculator. So 15 divided by the cosine of 36, 18.54. So that tells me Z is 18.54. Look at these triangles. Solve for angle theta. So looking at angle theta, the side 12, that is the adjacent side. The side 19 is the hypotenuse. The trig function that deals with adjacent and hypotenuse is the cosine. So the cosine of theta is going to be equal to 12 over 19. Now I'm solving for the angle. Use your inverse trig function. Theta is going to be the inverse cosine of 12 over 19. So the inverse cosine of 12 over 19. So trig function, inverse cosine of 12 divided by 19. So 50.83. So this is 50.83. I solved for an angle. It's measured in degrees. Solve for angle theta here. If you look at angle theta, this is the opposite side. This is the adjacent side. So I know that the tangent of theta is equal to the opposite over the adjacent. That means that theta is equal to the inverse tangent of 19 over 12. So the inverse tangent of 19 over 12, inverse tangent 19 divided by 12, 57.72. So 57.72 degrees. And that should take you up into working problems like this, classwork and or homework. So be sure you're grounded in this because these will start to show up in word problems as we go on.